if you're trying to use a formula like the one for gravity or like point charges in physics, these can be pretty error prone in the calculators because you're just combining the numbers wrong. So the best way to double check this is using a trick that I call front number, back number. I've got a previous video on that as well as on using this in dimensional analysis. I would watch those before this, but you might be able to just dive in here. Probably would be fine. So if you have a force of gravity, you've got this constant, and then you've got the mass of one of them, of the objects, and the mass of the other object, all over this distance squared, the distance between them. So this formula, you're oftentimes combining things, almost all of these in scientific notation, and it can get really tricky for a lot of people. So if we take this 6.674 times 10 to the negative 11 nanometers squared, kilograms squared, that's our G constant. And we've got our first mass. Sorry about the neighbor's dog. Hopefully you like dogs. We've got one of these masses is 1.6 times 10 up to the 20 kilograms, and the other mass is 100 kilograms, and that is all over the distance between them of 1.5 times 10 up to the third meters, and that should be squared. That squared here is really something that sometimes I forget, and that can mess me up a little bit. One of my favorite things to do here is just get not the place value, but the number that I should be getting. If you're on a multiple choice test, this is going to be such an easy problem to just see if you're correct or not. So you can combine all of these front numbers. So you've got that 6.674 times that by 1.6, and then times it by 1, and then you're going to divide that by 1.5. That's squared, so we're going to do that again. And we should have like a 4.7 or 0.474 if I just were to combine those front numbers as is. Now our final answer is going to have more to it than that, but we're only going to have like two place values being significant, so this is probably in excess to put any more on that. And that was from looking at this part, that part, that part right there to get right here. In addition, we can take our exponents and combine what we've got there. So it looks like we've got like 10 to the negative 11 plus positive 20, and 100 is the same as doing 10 up to the second power. So we're adding another 2, and that's all at the top. And then you're subtracting 3, but there's actually 2 of them because you're squaring. So you're subtracting 3 twice because of that square. If you wanted to rewrite this out with 1.5 times 10 to the third power twice and just have them next to each other, that might help you out visually with that as well. And then we just do a little simple math. You've got 11 and 20, so what's that? 9 plus 2 more, that's 11, minus 6, so that would be like up to the 5th power, right? So just double checking that, because you know that is a number of numbers that we're combining there. We've got negative 11 plus 20, get that out, that notation. That's 2 minus 3 minus 3, yeah. So that should give us our number, a pretty good estimate of that. We got 4.7 and 10 to the 5th power. But to make this actually be 4.7, we're going to need this number to be a bit bigger, so we want this number to be a bit smaller, probably. So I'm seeing 4.7 times 10 up to that fourth power, if I were to do that front number, back number trick. Combining this with the calculator is a bit painful. We will do it. But like, you'll see how long it takes in comparison. It's nice to be able to double check this and know if it's correct, because you don't want to do this calculation multiple times, right? So we got our front, our very first number there. We're going to times that by 1.6 times 10 up to that 20th power. And then we're going to times that by 100. And then we're going to divide that by 1.5 times 10 up to the third power. And then we're going to divide that by 1.5 times 10 up to that third power. And we get 4.7 times 10 up to the fifth power. Now there's a small mistake in here. Let's see where we went wrong there. I found the mistake. This was actually fine as is. This was actually 4.7 already. So we didn't even need to move over the place value. It was already in the 10 up to the fifth, which was correct when we had that written as 4.7 times 10 up to that fifth power. But if you did have to move it over, kind of nice to see how you would do that. So I'm going to keep it in the video. It's good to see mistakes. We're all human, but you should be able to double check it, because the machines, they just do the calculation and they're listening to us. So if you're plugging things in wrong, it's going to do it wrong, right?